Have you ever stood under the sun and wondered, how does this giant ball of fire in the sky power our homes, cars, and entire cities? Solar panels look simple, just flat, dark rectangles, but inside them is one of the most precise and fascinating manufacturing processes in modern technology. Today, we're going behind the scenes to see how desert sand turns into electricity, how crystals are grown like diamonds, and how thousands of tiny wires capture sunlight, one photon at a time. This is the surprising story of how solar panels are made. It all starts with something incredibly common: silicon, the same element found in beach sand. Factories heat purified quartz at extreme temperatures, above 2,000 degrees Celsius, to extract raw silicon. But this silicon isn't pure enough for solar cells yet, so it goes through a process called refining, where it's cleaned until only one impurity remains per billion atoms. At this level of purity, silicon can behave exactly the way we need for turning sunlight into electricity. Then comes the most delicate step. The silicon is melted again in giant furnaces, and a single crystal seed is dipped inside. Slowly, it's pulled upward, growing into a perfectly uniform crystal cylinder called an ingot. This method is so precise that even a tiny vibration can ruin the entire formation. Once the ingot is ready, high-precision saws slice it into razor-thin wafers, only about 0.2 millimeters thick. Imagine slicing a giant silicon sausage into hundreds of shiny, translucent chips. Each wafer is then polished and textured so it can trap sunlight instead of reflecting it away. This roughened surface is why solar panels look matte instead of glossy. Now the real magic begins. The wafers are chemically treated to create two layers, one slightly positive, one slightly negative. Together, they form a p-n junction, the heart of a solar cell. When sunlight hits this junction, it knocks electrons loose, and with a built-in electric field, those electrons flow in one direction, creating electricity. To capture this flow, machines print ultra-thin silver grid lines on the surface of each cell. These lines look delicate, but they're strong enough to carry the electrical current from every corner of the cell. Finally, the cells are baked in special ovens to lock everything in place. Dozens of finished solar panels are laid out in a perfect grid. Robotic arms connect them using flat metal ribbons. Then comes the sandwich, a sheet of tough, clear glass, a protective layer of EVA plastic, the solar cells, another EVA layer, and a weatherproof backsheet. All of this is heated and pressed together in a process called lamination, forming a permanent, airtight seal. A sturdy aluminum frame is added, along with junction boxes and wiring. And suddenly, the thin wafers that started as beach sand have become a functioning solar panel. And that's how sunlight becomes electricity, through crystals grown like gemstones, metal printed thinner than human hair, and layers fused tighter than anything humans made a century ago. From sand to silicon to power. If you enjoyed this breakdown of a surprisingly complex everyday object, make sure to like, share, and subscribe. There are many more simple things with incredible stories waiting for you.